Okay, this one actually gets asked every time I teach this course. It's a tough question, no doubt. So, what's hard about it is the drawing and kind of the visualization. So, you have a pyramid of height h and a base, an equilateral triangle of side length a. So, if you visualize this, these are side lengths a, and a, and a, and it rises up to become a pyramid. And then you're going to take a slice in here, and you want to know for that slice, what is its area? Because you're obviously going to slice these up and stack, right? So you're putting these little plates in here. So you need a relationship between that base. Now, I am admittedly a terrible artist, so I just imported an extra little piece of artwork here that I'm going to move over. There we go. All right. And so the artwork that I've imported here, you have the side lengths A. Those are equilateral triangle bases. And then at some height, which this height I'll just say is y sub I, we have a plate here. That plate, if I took it out, would look like, sort of like this. Again, not the best artist, but it would look something like this, right? So like a triangular wedge of cheese, and it has a thickness, delta y, and it side length alpha, side length alpha, side length alpha. I'm going to go ahead and use a little trigonometry here. Actually, it's not really trig, it's a little geometry here. So let's go ahead, and I'm going to tilt that plate, that equilateral plate up so that we can actually see it. So let me go ahead and do that. That's somewhat equilateral. Now, the way I've drawn that in here, this is side length alpha, that's side length alpha. And then we have some altitude here. Now remember, it's supposed to be equilateral triangles, so that's 60 degrees, and therefore this is 30 degrees. And this length down here is alpha over 2. And from our trig courses, or even just from basic algebra, we know this is root 3 over 2 alpha as well. So the surface area of that piece is 1/2 base times height, right? So the area of that ith slice is equal to 1/2 base times the height. And there are other ways to do this. And actually, when I copied this this graphic here, I copied it because I can't draw very well. I copied it in from the solutions manual. Not that I was looking at the solutions manual, but I needed a good drawing. But I'm not doing it the way the author does this. I'm actually doing this pretty much my own way. So 1/2, the base, actually the full base of this is alpha. So that's what I'm going to write here, 1/2 alpha. And then the height, we've just computed to be root 3 over 2 alpha, and that's just using basic trigonometry there. So the area of that ith slice is going to be root 3 over 4 alpha squared. And now I'm just going to stack. It also has a volume, by the way. It has a thickness of delta y. So the volume of that ith slice is going to be root 3 over 4 alpha squared delta y. Now what we're going to do is we need to find out what alpha is. Remember, alpha is kind of this base here at a height I. We have no, y sub I that is, we have no idea what that length is. However, we might be able to develop a relationship between that alpha and the true base A. And the way I'm going to do this is kind of how I do my decreasing, what do you call it? Like when you do a work problem and you lift an object that's leaking water, it starts at 70 pounds and it ends at 35 pounds, that type of thing. That's how I'm going to do this. I'm going to say this side length initially started at a length of A. It'll end at a length of 0. So it's going to lose all of its length by the time it gets up to the top. So let me write that down. I'm going to say that it starts at a length A, but we're going to lose A for every H that we go, right? Starts at a length A, And for every h in height we go, this distance up here, we're going to lose a. So it loses a per height h. And now we're going to go ahead and multiply that by the height that we're currently at. If that doesn't make sense to you, it might make better sense if I say side length. We have some initial side length, and we're going to lose a bit of side length. I don't know if this will make any more sense to you, but it might, for every distance in height that we go. But if you take a look at that, those units don't make sense. Side length is a length in meters, minus side length over height, meters over meters. So I have meters minus 1. That doesn't make sense. So I'm going to have to multiply it by a distance. And so I'm going to multiply it by the current height, which is also, let's just pretend, in meters. And that's how I get side length A minus side length A divided by the total height multiplied by the current height. That is actually what alpha is equal to. Side length A minus, we lose that much side length for every h units of height we gain, and we are currently at y sub I. So I'm going to replace alpha in this volume formula with this statement. It's kind of a different way to do it. If you look up solutions or something like that, they will not do this. But this to me is a little bit easier to work with than what some other people might do. So I have a minus a over h, y sub I, quantity squared, delta y. This is actually ready to go. So here I go to find the true volume. Root 3 over 4 can be factored out of the integral. We're starting an integral at a height of 0, and we're going all the way to a height of h. Both those terms within that square have a's, so I'm going to factor that out. A squared, and we have still 1 minus y sub I, oops, not y sub I anymore, but y over h quantity squared dy. And of course, a is a constant, so you can factor that out front. So I have a root 3 over 4, integral from 0 to h, and I'm going to multiply out this square. That's going to be 1 minus 2 of those y over h's plus y squared over h squared dy. Integrating with respect to y, I get y minus y squared over h plus y cubed over 3h squared, and this is evaluated from 0 to h. And that leaves a root 3 over 4 times h minus h squared over h, which is h, plus h cubed over 3h squared, which is 1/3 h. And if you plug in the zeros, they just disappear. And so this ends up being root 3 over 12. And I slightly miswrote this. There was an a squared up here, so all these are actually a squareds. So let me just fix that. And there we go. Completely done.